Welcome to the short-term training program on the Moodle Cloud on the topic the data structure tree. So a tree is not arranged sequentially. A tree is not arranged linearly. A tree looks like a bunch of grapes or a bunch of nodes connected together. Hence a tree is a non-linear data structure. So let's try to understand what are the typical parts of a binary tree, how it can be represented, and also how it can be viewed entirely. So this is a picture showing the parts of a binary tree. So as you can see, the root node or the main node is residing at the top level, unlike in the natural tree wherein the root is at the bottom. So this is like upside down, but that is how the beginning of a binary tree is. So a root is at level 0. Then the two of its derivatives b and c are at next level, that is level 1. Why do we have these levels? Because to indicate the hierarchical derivation. So a is a parent of b and c. B and c are its derivatives, hence they are at next level. Similarly, d and e are the child nodes of b, f and g are the child nodes of c. A typical tree with a parent and two children can be called as a subtree. So this is a left subtree starting from B, and this is a right subtree starting from C. So the nodes from which there is no further derivative can be called as the leaf nodes or the terminal nodes, and the other nodes from which there are derivatives can be called as the non-terminal nodes or the non-leaf nodes. Two nodes which are at same level and are derived from a same parent can be called as siblings. So here F and G are siblings. Similarly, D and E are siblings. But E and F are not siblings because they belong to different parents. And this hierarchy of levels you can understand. Suppose if A is a grandparent, B and C are parents, D, E, F, G are children, and then H, I, J are the grandchildren. So that is to indicate this hierarchy, we use the levels. Next, how can we represent this tree in the computer? Because each node needs to store some information. Also, it needs to connect to two of its children. So connecting here means storing the link field or the address of their children inside the parent. So it has to store the address of two child nodes, it has to store an information. So all this is a heterogeneous information. So hence we choose the heterogeneous collection of elements, that is a structure, to create each of these nodes. So here the mid field is the data field in which we store the value. Then we need to connect the left child and the right child. As these two are addresses, we need a pointer to store the addresses. Also, they are pointed to another node of same type. Hence, we have a pointer to a structure of same type node. So, left child and right child. So, when further the nodes come in or further derivatives come in, we need to create an instance of this abstract data type and then link them accordingly. So how to link them? So following the rule of a binary search tree. So what is a binary search tree? So in order to create a binary search tree, we need to follow a rule. The rule says that in a binary search tree, the left subtree is always lesser in value than that of a root, and the right subtree is always greater in value than that of a root. So that is binary search tree for you. Let's take an example. So if I have the first node coming in as 10, it will be placed in the root position. Then comes 5. Because the 5 is less in value than that of 10, it should be placed in the left subtree. Then comes 20. Because 20 is greater in value than that of 10, it should be placed in the right subtree. So this is how we create the binary search tree. So we need to follow this rule in the further derivation as well. So here is a binary search tree creation. So this is a reflection spot. I would want you to pause the video and try to construct the binary search tree following the rule of left subtree less than root and right subtree greater than root. So these are the typical nodes coming in. So starting from 4 and then comes 2, 1 and thereon. So using these nodes as the inputs, coming in serially starting from 4, I would like you to construct a typical binary search tree. So pause the video for a moment and try to construct your own binary search tree in your course journal, following these as inputs given in order. So I hope by now you have constructed your binary search tree. So let me construct it for you so you can match up your answer. So first is coming 4. So in empty binary search tree, it goes into the roots position. Then following nodes will be positioned with respect to the value of root node. So 2 is coming in. So 2 is less in value than that of 4, the root node. So it needs to go to the left subtree. Then comes 1. So 1 is less in value than that of 4. So we go left. Again 1 is less in value than that of 2. So we go to left again. Then comes 5. 5 is greater in value than that of 4. So we move to the right subtree. Then comes 3. 3 is lesser in value than that of 4, so we move to left. But 3 is greater in value than that of 2, so we move to the right subtree. So here is where 3 finds its position. Lastly comes 6. 6 is greater in value than that of 4, so we move to right. But again 6 is greater in value than that of 5, so we move to right again. So here is where 6 finds the position. I hope you constructed the same tree, answering the reflection spot. Let's move ahead. So this is how your typical binary search tree would look like, following the binary search tree rule. So after you have constructed the tree, how can you visit the tree reaching all of its nodes? So how can a user view a tree on screen? So that is what we need to understand. So for that, there is the concept of traversal. So what is traversal is, it's a process of visiting all the nodes in a tree, and also you may print those values without missing any nodes. So there are 3 ways to do this traversal. So we have in order, pre-order and post-order. The in, pre and post are with respect to the position of root node. So in order, the root is placed in between the left subtree and right subtree. In pre-order, the root is placed pre-positioned to the left subtree and right subtree. And in post order, the root is placed after the left subtree and right subtree. So you can see in all the 3 traversals, we always visit the left subtree first or prior to the right subtree, but the in, pre and post are with respect to the position of root node. So following this rule, let us take an example of a binary search tree which we created earlier of 5, 10 and 20. Left subtree less than root, right subtree greater than root. So the in order of this would be left subtree, root and right subtree. So we have 5, 10 and 20. Pre-order would be root, left subtree and right subtree. So 10, 5 and 20. Post order would be 5, 20 and then 10. So 5, 20 and 10. I hope you understood the tree traversal. So let us do it for a slightly bigger tree. So here we have in order. So here we have 2, 4, 5, but 2 is not individually present, it is further having derivatives. So again this rule needs to be applied to this subtree as well. So here we have 1, 2 and 3. So now you are done with the left subtree, 1, 2 and 3. Then comes the root, 4. Then again here we need to follow the binary search tree rule. So there is no left subtree, so directly we have root and then right subtree. So 5 and 6. So the order becomes 1, 2, 3, 4, 5 and 6. Also you can see that if you strictly follow the binary search tree rule while creating a tree, and if you have an in order traversal display of it, you can see the tree is displayed in ascending order. Bingo. So next comes pre-order. So in pre-order we have root, left subtree and then right subtree. So root is placed first, that is 4. Then we have the left subtree, but again left subtree is having further derivatives. So here also we need to follow the rule of pre-order, that is root 2 first and then left subtree and right subtree 1 and 3. So 2, 1, 3. So now left subtree is done. Then comes right subtree, again follow the same rule. So root first and then the right subtree. So 5 and 6. So this is the order: 4, 2, 1, 3, 5, 6. Lastly comes post order. So here comes left subtree, right subtree, and then root. So left subtree is having further derivatives, so follow the same rule again: 1, 3, 2. So now you're done with the left subtree. Do the right subtree: 6 and then 5. Right subtree is done. So lastly we have the root node placed at the end. So that is post order traversal for you: 1, 3, 2, 6, 5, and 4. I hope you understood what a typical tree looks like, how it can be represented in the computer, and also how it can be viewed entirely. Thanks for watching.